Hi, what's up guys, this is Jayanam with a new Python beginner tutorial about the binary search algorithm, very important for fast searches in sorted lists. Okay, so let's go ahead and create a new file here in Visual Studio Code called search.py and then add a simple list with ordered numbers. After that we create a function to search for a special item in such a list, but this is not going to be the binary search, it is just looping through the list and compare each number in it with the number we are searching for. The function will return the found index or -1 if we haven't found the item. I use enumerate in this for loop so that I get the current index and the value for each iteration of the loop. Okay, first I check if the current value is larger than the search item, then I know that the search item is not in the list because it is sorted, and at this point we can return -1. In the else case I check if the current item is the one that we are searching for, and then I return the current index. The last case is that we fully went through the loop without finding the item, so we have to return -1 as well. Okay, now let's test if this function works as expected. I call the function and store the result in a variable named foundIndex. If it is found, I print out the value of the list with the found index, and in the other case I print not found to the console. Okay, then I start the program and yes, it works, but now let me show you the drawback of this function, and this is the performance for large lists. I use a range to increase the size of the ordered list to a very high value, for example 100 millions, and the search item I set to the size of the list -1, which is a very bad parameter for the function because we have to loop through the whole list to find the item. And then I start again, and as you can see we have to wait about 10 seconds. That's a bad performance, so I think it's time to change to binary search. Let me use an example to explain the algorithm. Okay, assume that we have a sorted list of 13 numbers and we are searching for the number 37. First we initialize two variables, left and right, to the first and the last index of the list, and then set a variable called middle to left plus right divided by 2 and do a floor operation for the result. So the middle index in this case is set to 6. In the next step we check if the search value is smaller than the number of the index in the middle, then we set the right item to middle -1, and then again set the middle to floor left plus right divided by 2. Now once more we check if the search value is lower than the middle item, but it is higher, so we set now the left index to middle +1. Again the middle index to left plus right divided by 2, which is 4 in this case, and we found it and return the middle index. So that's it, let's code. I add a new function which I call binary search with the same parameters as the simple search. I introduce a left and right variable and initialize these to the start and end indices of the list. Okay, then I loop while the left index is smaller or equal to the right index. In this loop I set a middle index variable to a value that is the floor of left plus right divided by 2, and then I do the check if the search item is smaller than the value in the middle. If this is true, I set the right index to middle -1, and if it is larger than the middle value, I set the left index to middle +1. In the else case, when the item is equal to the middle value, we found the item in the list and return the middle index. Well, and if we haven't found it in the loop, we just return -1. And that's the algorithm. Alright, and now we can replace the simple search call with the binary search call, but use the same parameters. And as you can see, a search that took 10 seconds is now done in 0.092 seconds with the binary search. I can also use a different search value, doesn't matter. The execution time of the binary search is about the same. So guys, I hope you understand that using the right algorithm is more important than, for example, having a fast CPU. So keep this in mind, it's very important also for game programming. So if you like these Python tutorials, let me know. Don't forget to subscribe to this channel if you haven't already. And if you have any questions, then add these to the comments below and I will try to answer these as best and soon as I can. Thanks for watching and see you in the next one.